This is the unit, polar unit. Folks are going to learn about going from rectangular to polar coordinates and vice versa. Basically, in rectangular, every point is unique, every x and every y is unique. In polar, it's not. I can name the same point. I can call it 0, I can call it 2 pi, 4 pi. Points are not unique in polar, but they are unique in rectangular. Okay, converting polar to rectangular. Polar will be in the form r comma theta. Rectangular will be in the form r cosine theta and r sine theta. This here comes from cosine of theta is equal to x over r adjacent over the hypotenuse. And if we were to solve this for x to be able to put it into rectangular, this would be r cosine of theta is equal to x. And the same thing for sine. Okay, here we have two equations that we're going to have to use when we're converting back and forth so we can manipulate these formulas. All right, when you're converting rectangular to polar, you're going to find your points that you're given are in x and y, and you're going to have to do some manipulation to get them in the form of r comma theta. All right, these are some important side notes to keep in mind. It'll help you go from converting polar to rectangular and vice versa. R squared equals x squared plus y squared. And we also remember cosine squared plus sine squared is equal to 1. All of these formulas are derived the same way. We can solve for r and get r equals the square root of x squared plus y squared. If you're ever asked to find the angle, here's a way to find the angle. Use the inverse tangent of your y value over your x value, and you can get the angle that we're the respective angle. All right, one of our practice problems, we're going to find the polar equation for the curve.
So we need
and
r.
Here is the equation right here. X times the square root of x squared plus y squared is equal to 2y. All right, so basically, folks, what we're doing now is we did a substitution trying to convert over. So we substituted the x for r cosine theta. We substituted square root of x squared plus y squared for r, and we did the same thing for the other side. Okay, right here, we're going to try to get r by itself. So we're going to divide through by the cosine of theta on both sides, r cosine of theta on both sides, and let's see what happens. Okay, once we simplify that, we get r equals 2 sine of theta, and sine theta over cosine of theta is tangent. Our final answer for the polar equation is r is equal to tangent of theta. Okay, we're going to show that r equals 4 sine of theta is a circle. Let's see what we can do here. Okay, and so we multiply both sides by r. We have r squared is equal to 4r sine of theta. We did a substitution right here with r squared because it is definitely equal to x squared plus y squared. We did a substitution here with r sine theta, made it y. Now what we're going to do is we're going to pull this over to one side, see if we can complete the square, and find out what this circle is doing. Okay, so now we brought it over here. We did complete the square. We took half of our linear term, made it -2. We squared -2 and made it +4. We just created +4 on the left-hand side of this equation. To offset it, we add 4 to the right-hand side of this equation. All right, your objective this week is to graph polar curves, to investigate their properties. We'll have curves sometimes where you'll have to find the points of intersection, which is going to be a straight. Put it in the calculator, y1, y2, see what it intersects. We're going to be able to find the area of enclosed portions of the polar graph. Integration, hint. We're going to be able to find arc lengths, perimeter, the outside of the loops. There we go. Polar curves are going to be represented like this. R is equal to F of theta. Okay, here's a circle with the center on the polar axis. If you have r equals a cosine theta, your circle stretches out along the x-axis. Also, r equals a sine of theta, Sine is your y-axis, so it stretches out against the y-axis. If A happens to be negative, all it does is go in the opposite direction. All right, so here are the rules so you can figure out what type of limison. They're all limisons. We just call, this one has a specific name, cardioid, where A is equal to B. We have an inner loop, we have a cardioid, looks like a heart, and when it's kind of like a flattened look, it's still limison, whatever the heck it is, A is greater than B. Hit record on this.